GALEX is a NASA Small Explorer class mission. It's an Earth-orbiting space telescope designed to observe in the ultraviolet. It's not very big, it's only about 50 centimeters in diameter. It was launched in April of 2003, and it orbits about 690 kilometers above the Earth.
It's an international collaboration between the United States, France, and Korea. It's managed by NASA and JPL as well as Caltech. The purpose of the satellite was to investigate the ultraviolet sky and to survey the entire sky for the first time. It's called the Galaxy Evolution Explorer because the purpose was to explore the evolution of galaxies from the present to at least halfway back to the beginning of the universe. In addition, GALEX offers the opportunity for guest investigators or guest scientists to use the telescope for their own investigations into UV astronomy. So the ultraviolet is a portion of the spectrum that is bluer than what our eyes can see. It's just beyond the edge of our blue edge of our sensitivity. It tends to be absorbed, a lot of it that we're interested in is absorbed by the upper atmosphere. So that's why we were motivated to put a telescope in space to explore the ultraviolet universe.
And the reason why we observe it is because we're looking for star formation. And young stars, which tend to be massive stars, emit most of their light in the ultraviolet. So if we want to measure the star formation rate in galaxies, the best way to do that is in the ultraviolet. We've been finding star formation in some really unusual places. M83, a nearby spiral galaxy, is a perfect example. We see star formation extending out 4 times the optical disk of this galaxy in places where we had no idea star formation was occurring at all. We also find little hidden treasures. The ghost of Meroc is another nearby galaxy.
So in the optical, all you can see is what appears to be an old dead galaxy. In the ultraviolet, the star is much fainter and the galaxy starts to shine forth. What we see in the ultraviolet is that, in fact, there's ongoing star formation and it's not anywhere near as dead as we thought it was. Another interesting place is some primordial gas that we found in a ring around a group of galaxies in the constellation of Leo. People have known about this primordial gas, but they've been unable to find star formation in it. GALEX, with its sensitive UV detectors, was able to definitively detect ongoing star formation in this ring.
A little closer to home, GALEX also observes stars. Now, this was not the primary mission of GALEX, but we actually can't help but look at stars in our own galaxy, since we have to look through the galaxy to observe the galaxies beyond our own. And this has also led to some great surprises. A perfect example of this is Mira. Mira is a very old, what they call red giant star. We didn't expect to see this object in the ultraviolet at all. It turns out not only do we see the star, but we see it plowing through space at an amazing speed. And in the process, it's shedding off material and leaves a tail very much like a comet behind it.
People have been imaging and studying this star for 400 years, but until GALEX looked at it in the ultraviolet, we didn't know that in fact it has a tail streaming behind it that's 13 light years long because of this motion and because of the shedding gas. Another interesting thing that we found was an interacting binary star, 2 stars that share matter between the 2 of them. And we see some incredible structures that basically are the traces of explosions that happened because of this interacting matter. And GALEX was the first satellite, first chance to observe the traces of this explosion. So GALEX has a lot to look forward to. We are observing the sky in certain places. We're going back time and time again, and this allows us to determine for the first time the sort of general variability of sources in the ultraviolet. We also are archiving all of our image data so that we can keep track of what's been observed and study objects in detail. This archive is going to be publicly available. It is currently publicly available through the web to anybody. So there's a tremendous amount of data being generated by GALEX. The images are very large, and it's impossible for professional astronomers to actually put their eyes on every single image. So it's an opportunity for the general public to download the images and look at them, and maybe you'll discover something like Mira.
Currently, we've imaged about 3/4 of the sky in the ultraviolet at various exposure times. and we continue to fill in regions as the mission continues. This is going to be the standard ultraviolet database for the next decade. There's a tremendous amount of data, and there are so few eyes to actually look at it. So go out there and make your own discovery.